Right, so here's a rate of change question, but it includes proportionality. So we've got a fluid flowing out of a cylindrical tank with a constant cross section. So let's draw a diagram. So here's our circle, make a constant. So if you've got a constant cross section, that means it's basically that the radius is constant throughout. So there's our cylinder. Okay, right. So we've got our cylinder, and we are told that the rate of change, the rate at which the fluid flows in meters cubed, so that's going to be volume, is proportional to the square root of V. So the rate at which the fluid flows, we know that must be the change in volume as it's in meters cubed, and that's happening over time as the liquid's flowing out. So we've got dV by dt, and that is proportional to the square root of V. Okay, so we have to think back to a bit of GCSE maths. Okay, to make this into an equation, that means dV by dt is equal to K times the square root of V. Remember, K is our constant of proportionality. Now, this is a negative rate that's flowing out, so I'm going to make that negative. Negative K times V. Right, well, let's think about our object. We know that the volume of the cylinder is equal to pi r squared h. Okay. Right, now, as it has a constant cross section, that means that this is actually constant. It's not changing. Okay, R is the same all the way through our cylinder. R here is the same as R here. Okay, so this is a constant. So what we can do to make it simpler to understand is we can rewrite this as A H. Okay, and A is basically just representing pi r squared. We'll look later at why that is. Okay, so now that's our constant. So now if we differentiate, we can differentiate V. You have to do it with respect to the constant. And the constant that we've got is H. Okay, so dV by dH, okay, H becomes 1, so we've just got A. Okay, so the derivative of the volume, okay, or the rate of change of the volume is a constant. Okay, right. So now let's look at dV by dt. Or actually, let's put them all together. So the question says we want to show the depth h of the fluid in the tank satisfies the differential equation dH by dt. So how do we find dH by dt? We know dH goes on top, multiplied by another derivative, and that has dt at the bottom. So now we need to fill in these two places. Well, what's the other variable that's here? Well, that would be v. So dv, dv, and then these two, when we multiply them, will cancel each other out. Right, so now we know what we want. So we've got dv by dh here. I want dh by dv, so we know that basically we can write that as the reciprocal. So I'll put 1 over a. And that's going to be multiplied by dv by dt, which we need to find. So dv by dt is minus kv. Okay, we don't know what k is, and we don't have an example to find out what k is. But if I've got that dv by dt is equal to minus k times the square root of v, well, v we defined as being a times h. So I'm going to replace that with ah. So dv by dt becomes minus k times the square root of a times h, the thing we defined the volume as. So now let's put that into dH by dt. So dV by dt is minus k times the square root of ah. Remember, a is our constant. Okay. So that means it equals minus k square root of AH, all divided by A. Right, we can simplify this because we've got two A's appearing. So we get minus k square root of H over the square root of A. Okay, so now we want to work out dH by dt, and we wanted a constant times the square root of H. Okay, so we wanted that constant k, and that is going to be is equal to our constant of proportionality divided by the square root of A, which was the constant we defined at the beginning. So that is the answer to the question. Let's have a look at this. If we did the same thing with pi r squared rather than A, does it work? Do that in a different color. Okay, so now, if I say that V is equal to pi r squared H, then dV by dH is going to be pi r squared, because we're only differentiating with respect to H. So that this is my constant, so it's the same. Okay. And if I put pi r squared instead of A times H into my volume, okay, I get dV by dt is equal to minus k times the square root of pi r squared H. That's my dV by dt. Now remember that my dV by dH, I'm going to flip that upside down, so that's going to be 1 over pi r squared. So when I do my combined derivative, dH by dt, I have minus k square root of pi r squared H divided by pi r squared. Okay, so it works exactly the same way. The key thing is that our pi r squared is a constant. Okay, so we can rename it if it's easier to work with, but it's just a constant. So the answer is that k is that when dH by dt is equal to something times the square root of h, which was the question in the beginning. I hope that's a bit clearer. If not, let me know.